Hi there, this is Math 2, Unit 5, Worksheet 2, working with properties of parallelograms today. Okay, the given figures are all parallelograms. Solve for the variables in each diagram, then state the property of parallelograms that allowed you to solve for the variables. Okay, so this one here, when we look at this, the property that allows us to solve this, first of all, is recognizing that consecutive interior angles are supplementary. Okay, what that means is that x plus 51 is going to be equal to 180 degrees. Okay, and that's what that means. So to find out what x is going to be, I subtract 51, and x is going to be equal to 129 degrees. And that's all there is to that one. Down here, number 2, it says that DG right here is equal to 2x plus 2. DE is equal to 3x plus 1. EF is 3x minus 3. And GF is 2x plus 6. Okay, so in order to make this work here, what we need to know is that opposite sides of a parallelogram are congruent. If opposite sides are congruent, then that means that this one equals this one, and this one equals this one. Okay, so I can set it up and say, well, let's do 2x plus 2 equals 3x minus 3, and make that equal to that. So I subtract 2x, subtract 2x. Alright, and so that becomes x over there. I can add 3, and 2 plus 3 is 5. So what does x equal? X equals 5. Number 3, we're trying to show that that perhaps equals that, and the property for that is that opposite angles are congruent. In a parallelogram, opposite angles are congruent. That means that 40 equals 3a minus 5. So to solve that, I add 5 to both sides. We have 45 equals 3a. Divide both sides by 3. And 15 equals a. For number 4. Okay, we've already used this one here. We've already said that, what do we say? Opposite sides are congruent. So that means that those are going to equal each other, and these will equal each other. Let's solve for x and y. So here's x, 3x minus 5 equals 2x plus 2. I subtract 2x, that becomes x. I add 5, that becomes 7. X equals 7. For the y, I do 2y minus 6 equals y plus 3. I subtract y, so I have y left over here. I add 6, and 3 plus 6 is 9, so y equals 9. And our last one down here, okay, these are looking at the measurements of those links right there. The property that allows us to figure this out is knowing that diagonals bisect each other. So diagonals bisect each other. That means that when they bisect, the parts are going to match. Okay, meaning that this line right here is going to match the length of that one right there. Okay, and this length right here is going to match the length of that one right there. Okay, so we can set them equal. Let's look at the pink one first. We can say that 11 equals 2x plus 5. I subtract 5. We have 6 equals 2x. Divide both sides by 2. And 3 is equal to x. The same thing for the y. The y, we're going to say that y plus 4 equals, in this case here, we have to plug something in, 2 times x. X is 3. We already said 3 plus 4. So 2 times 3 is 6 plus 4 is 10. So y plus 4 equals 10. Subtract 4, and y is going to be equal to 6. And that's the idea for that one there. All right, let's turn over to the back side. On the back side, can you prove the quadrilateral is a parallelogram based on the given information? In this case here, we would say we could prove that it is, and the reason we can say yes, is because the diagonals bisect each other. Okay, that's how we can prove that there. For number 7, with what we have these angles are equal to each other. We know that that's a true statement, which means it probably is a parallelogram, but we're not fully sure. So we would say no. And the reason we say no is there's not enough information here to really be able to tell us that or not. Okay? Because I'm not sure if those are going to be, or even if they match, not sure. Over here though, this one would work because we can tell that I have a couple things. I have those opposite angles. Opposite angles are congruent. Okay? And we also have here 136 plus 44. We also have that what we call them, the consecutive interior angles are supplementary. Okay, so that adds up to 180. Those are equal to each other, so we have a couple things that tell us this is probably going to be a parallelogram there. All right, and finally over here I'd do number 10, and we would say yeah, that's because opposite sides are congruent. Those are matching there. Let's take a look at a few more as we wrap up here. We're looking at 12 and 14, 16 and 17. Okay, so for what values of x and y must each figure be a parallelogram? All right, if they're going to be, if we could look at a couple things. We could look at the consecutive interior angles being equal to 180. That could work for us. So let's start there. Let's look at the x. We're going to say that x plus 5x minus 180 is equal to supplementary 180. So we can put that together and say 6x equals 180 added over there equals 360, which means x is going to be equal to 60. That's my first value. And for the y, we would say that 4y plus 2y equals 180. So 6y equals 180. Divide both sides by 6, and y equals 30. So that's how we do number 12. For number 14, we're looking at these line lengths here. We know that x is going to be equal to 2y, and we know that this 2x plus 14 is going to be equal to 5x minus 4. Because this one has two variables, x and a y, let's start with the long length here and set them equal to each other. Let's do 2x plus 14 equals 5x minus 4. So it's minus 2x over here, so we get 3x is equal to, we'll put the 4 over there, plus 4, 18. Divide both sides by 3, so that x equals 6. In good shape there. Now we can use that information to then solve for this. Those equal each other, meaning that x equals 2y. Because x was already 6, we can plug that in there. So 6 equals 2y, divide by 2, and 3 equals y for the answer for number 14. On number 16, it says a classmate draws a parallelogram for which one side is twice as long as the other. If one side is 26 units, what are the possible lengths of the perimeter? So we're looking for the perimeter here, so be careful about what it's asking you to do. Okay, so if one side is 26, let's give a couple pictures here. I could have a parallelogram that looks like this, and the short side could be 26, right? If the short side is 26 and one side is twice as long, 26 times 2 is 52, 52, and the perimeter for that shape, when I add all that up, is going to be equal to 156. I also have another option too. I could have it where the long side is the one that's twice as long, which means that's my short side, and the 26 is twice as long as the other. And so it would look something like this. So I could have it be the short side or the long side. The perimeter of this shape, though, is going to be equal to 78. So I have two possible answers depending on whether 26 is the long side or the short side. Okay, and finally one last one just to wrap up the day with. We have a proof, which is good to kind of keep fresh in your mind. It says given parallelogram ABCD with AC, this length here equals BD. So we have two sides that are equal. We have two sides ready to go. Okay, what else can we do? I'm going to prove the triangle is going to work. So the next step, it says that opposite sides of parallelograms are congruent. So that would be something like this is congruent to that. So we could say that AD is congruent to BC. In doing that, we have a line that works there. We know that this line here is congruent to that one there, so we have a side and a side. The next step, it says that DC is equal to CD, so 1, 2, 3, and that is our reflexive property. Of congruence. So now we have a side, side, and a side, which we already said side, side, side is there. And so because of that, we would say that triangle ADC is congruent to triangle BCD. All right, that's it for today. Hope you have a great day. We'll see you next time.